Hi everyone, in this video I'm going to be going over the factoring and square root quiz review. So for number 1, we're given the graph of f of x and it asks for what values of x does f of x equal 5. So f of x, remember, is just another way of saying y. So I'm going to look on the graph at where y equals 5. And I want to see where my graph touches at y equals 5. So I can see that the x values where my graph touches at y equals 5 are at x equals -4 and x equals 2. So the x values where my graph has a y value of 5 is at x equals -4 and at x equals 2. Number 2 says given the graph of g of x, for what values of x does g of x equal -8? So again, g of x is just another way of saying y. So I want to look at where y equals -8 and then see what x values touch at y equals -8. So that's at x equals -7 and x equals -1 where it crosses. So x equals -7 and x equals -1. All right. For number 3, given the graph of h of x, for what values of x does h of x equal -4? So I'm going to look at where y is -4, which is down here, and I can see that my graph never touches y equals -4. So this one actually has no solution. There's no x values on the graph that touch at y equals -4. And for number 4, given the graph of j of x, for what values of x does j of x equal 4? So I'm going to look at where y is 4. And I see that this one actually only touches at one spot. That's at x equals -1. So this one only has one solution when y equals 4. So for part 2, the reasoning, it says, true or false, when solving a quadratic equation, you always get 2 solutions. Well, based on the graphs we just looked at, you can see that that's false because on the first 2 graphs, we got 2 solutions, but on the third graph, we got no solution, and on the last graph, we got 1 solution. So the answer is false, and then an explanation would be you can get 0 or 1 solutions also. So overall, you can get 0, 1, or 2 solutions when solving a quadratic equation. Number 2, when Aldrich is solving a quadratic equation by factoring, he gets the equation 2x plus 1 times x plus 5 equals 0. Explain why he can set each of the factors equal to 0 and solve them separately. Well, the reason this is, if you remember in our notes, we talked about the zero product property. So the zero product property, you need to be able to explain what that is in your own words. So the way I'm going to explain it is the zero product property says that when two terms, we'll call them A and B, multiplied together to give 0, then either A has to be 0 and or B has to be 0. So I'm basically just saying when you multiply 2 terms together and they're equal to 0, then that means one of the terms has to be 0. So however you say that in your own words is fine. I just said it very similar to the definition we learned. When A times B equals 0, then either A has to equal 0 and or B has to equal 0. That's the reason why you can set each factor equal to 0 to solve that a quadratic equation when you're factoring. All right, we're already on page 2. So solve each quadratic equation using the appropriate methods. Solve for every value of x. If necessary, round your answers to 3 decimal places and make sure you circle your final answer. So when you look at each of these equations, you have to remember that there's 3 different ways you could solve. There's square root method. There's factoring when a is 1. And then there's the box method, which you use when a is not equal to 1. A is the coefficient on x squared. So square root method we always do when there is only, I'll make a note, one x term that we see. So if I look at the first equation, 2 times 3x plus 9 minus 32 equals 40, I can quickly see that there's only one x. In other words, here's x. I don't see x anywhere else. That means we can use do-undo steps to isolate x, which means we can solve by square root method. So I'm going to make a quick do-undo chart for those of you who like those. So if I look at my equation, if I were to plug in something for x, the first thing I would do is multiply by 3. Then I would add 9. And I would square it. Then I would multiply by 2. I would go outside the parentheses, multiply, and then subtract 32. So you always do whatever's in the parentheses first, then the square, then what's outside the parentheses in order of PEMDAS. So to undo this, I got to follow my steps backwards. So instead of subtracting 32, I will add 32, then divide by 2. Now, remember when you get to the square root step, don't just write a square root, write a plus or minus square root, because you cannot forget the plus or minus when you're solving, or you will lose like half the points on the quiz, because you need to get both solutions if there are two solutions. Then you would subtract 9 and divide by 3. Okay, so now I'm actually going to follow these steps. So first thing I do is add 32 on both sides. So that leaves me with 2 times 3x plus 9 squared equals 72. Remember, you should always be doing the things outside the parentheses, then dealing with the square root, then the things inside the parentheses. If you're not doing that, then something is off with your do-undo chart. So then you would divide by 2. So you get 3x plus 9 squared equals 36. See, now we're left with something squared equal to 36. So that's how we know our next step is to take the square root of both sides. Now remember, on the side with the number, that's where you include the plus or minus. So when we take the square root on the left, we don't need a plus or minus because the square root just gets rid of the square. So it leaves us with 3x plus 9. And then the square root of 36 is 6, but it's plus or minus 6. This is the step where we get two different equations. Basically, this is saying 3x plus 9 can be positive 6 or it can be negative 6. And the reason for that is because positive 6 squared gives us 36 and negative 6 squared gives us 36. So we have to account for both possibilities. So I'm going to set up two separate equations. 3x plus 9 equals positive 6 and 3x plus 9 equals negative 6. And I'm going to scroll down just a little so I have a little more room. The rest I'm going to solve using my last two do-undo steps. I just have to make sure I'm doing it to both equations to get both solutions. So the next step is to subtract 9. So I get 3x equals negative 3. I also have to subtract 9 on my other equation. So I get 3x equals negative 15. And the last step for both is to divide by 3. So x equals negative 1. That's one solution. If I divide by 3 over here, I get x equals negative 5. That's my second solution. So again, the most important thing when you use the square root method, first of all, make sure that x is by itself somewhere so you can easily isolate it. And then when you take the square root, do not forget the plus or minus sign. All right, time to go on to the next one. I've got x squared plus 3x minus 37 equals 2x plus 5. Well, I need to think about what are my methods. Well, first, can I use square root method? The answer would be no, because I've got x's like all over the place, and I wouldn't be able to easily isolate it. So I'm thinking I'm going to have to use factoring. Which kind of factoring would I use? Well, the coefficient in front of my x squared is 1, so that means once I get everything on one side, I can use my kind of easier factoring method. You don't need to make the box or anything when you have a coefficient of 1 on x squared. But first things first, this equation is not set equal to 0, and I cannot start factoring until it's set equal to 0. So in order to get it equal to 0, I need to move 2x and 5 over to the left side. So I'll start with moving 2x. So to move 2x, it's positive, so I need to subtract it on both sides. As you can see, 2x and 3x are like terms. They both have a single x. So I can actually combine these like terms. So x squared is still x squared. 3x minus 2x leaves me with 1x. So I'm just going to write plus x. And then I still have minus 37 equals, equals 5. So it's still not quite equal to 0. I need to get rid of the 5, again, by subtracting 5. So as you can see, negative 37 and minus 5 are both constants, so I can combine the like terms there. So the x squared stays, the plus x stays. Negative 37 minus 5 gives me minus 42. And then I finally have 0 over here. So now I can finally start to think about how I can factor this. Well, the question will be asking what multiplies to negative 42 and adds to, well, I need to look at, I'm always multiplying to the constant, and then I'm always adding to the coefficient with x in the middle. And the coefficient here, some of you are like, it's 0 maybe, but no, the coefficient here is 1. So I need to add to 1. Multiply to negative 42 and add to 1. So I always start by making a factor table for 42, positive 42, and then I figure out the negative parts later. So I'm going to find factors of 42. So the first easy ones are always 1 and 42. I can tell 2 goes into 42. If you don't know what 2 multiplies by to get 42, just do 42 divided by 2 in your calculator. You get 21. And then just keep, 42 is kind of big, so you might need to just test some numbers out. So test out 3. If you do 42 divided by 3, you'll see that you get 14. So that is an even factor pair. 4 doesn't go in. If you divide it by 4, you'll get a decimal. 5 doesn't. 6 does. 6 times 7 gives you 42. So now I'm thinking, I know they need to multiply to be negative and add to be positive. So if they're multiplying to be negative, then one of the factors should be negative and one should be positive. And then they have to add to positive 1. So I'm looking at which pair has a difference of 1. Well, 1 and 42 has a difference of 41. 2 and 21 has a difference of 19. 3 and 14 has a difference of 11. 6 and 7 does have a difference of 1. So those are going to be my factor pair, but then I need to decide which one should be negative. Well, I need to add to a positive number, so my bigger number should stay positive and my smaller number should be negative. I can check that real quick. 7 times negative 6 gives me negative 42. 7 plus negative 6 or minus 6 gives positive 1, so that works. Now I just use these to make my factors. So x, x minus 6 times x plus 7 equals 0. Now this is where we get to use the zero product property. We set both factors equal to 0 and solve. So x minus 6 equals 0 and x plus 7 equals 0. And it's real quick to solve these. Add 6 on both sides on this one. That gives you x equals 6. Then this one you need to subtract 7 on both sides. And that gives you x equals negative 7. We have 2 solutions there. All right, let's go on to 2x squared minus 11x plus 5 equals 0. I first need to think, can I use square root method here? Well, I see that I've got x's in 2 spots, so I can't use square root. So I'm definitely going to want to use factoring. And I see that I have a coefficient of 2 with x squared. So I can't use the factoring method I just used. I'm going to have to think about using box method. So I always have to first check if my equation is set equal to 0, and it is. So that part's done. If it wasn't set equal to 0, I'd have to move terms like I did in the last example, but this one's good. So my first step is I need to take the number with x squared and the constant and multiply them. So 2 times 5, that gives me 10. So actually, my next step is to use 10, find factors of 10. So I'm looking for 2 numbers that, let me write it over here. I want to multiply to 10, and I want to add to negative 11, because that's my number in the middle. So I'm looking for numbers that multiply to 10 and add to negative 11. Remember, when I multiply 2 and 5, I'm not changing the equation. I'm not rewriting the equation as 2x squared minus 11x plus 10. I'm not rewriting it. I'm just taking those numbers, going off to the side, figuring out some factors, and then I'm coming back to the equation. So I'm not, when I multiply 2 and 5, I'm not changing the equation. I'm just doing it as a separate thing. And I'm going to look for factors that multiply to 10. So I'm going to think 1, 2, 10, 2, and 5. That's it. So I need these numbers to multiply to positive 10 and add to negative 11. If they need to add to a negative, then I should get 2 negative factors. That's the only way to multiply to a positive but add to a negative. So I need to think which of these could add to negative. So I know they need to be negative, 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 whichever one I pick. And I'm going to think which of these would add to negative 11. That would have to be negative 1 and negative 10. Okay, so we're not going to use that right away. We need to now make our box. So we make our box, split it into 4. Okay, so the easy parts to remember are always that 2x squared, or whatever the x squared term is, goes in the upper left, and plus 5, positive 5, goes in the bottom right. So 2x squared and positive 5 go in those spots in the box. Here is where the factors we just came up with come into play. I need to put negative 11x into my box, but I have to split it between 2 boxes. The way we split it up is by using the 2 factors we just found. So negative 10x and negative 1x, because those are the 2 numbers that multiply to 10 and add to negative 11. So the reason we can split it up like this is because negative 10x plus negative 1x is negative 11x, the number I have in the middle. So I'm just splitting negative 11x into 2 boxes. Remember, you could have this switched. You could put negative 1x in the top right and negative 10x in the bottom left. It doesn't matter. All right. Next step is to find the greatest common factor. You can either start with the columns or the rows. I think I am going to do the rows. So I want to find the greatest common factor of 2x squared and negative 10x. So if I start by just looking at the 2 and negative 10, I know the greatest common factor of that would be 2. And then x squared and x, the least amount of x's I see is 1x, so I'm just going to take out 1x. All right, for the bottom row. Now, I learned a new trick for this. Some people were really confused about when do you take the negative out as a common factor. So it turns out the only time, to make sure you don't get any mistakes when you're doing the box method, only take out a negative if you're on a side length that's touching a negative. So like you could take a negative out here because it's touching negative 10x. You could take a negative out here because it's touching negative 1x. But you can't take negatives out on any of the other spots because they're touching a positive term. So that should help you figure out. So since I'm touching the negative 1x, I'm going to take out a negative. So I just have to think, what would the common factor of 1x and 5 be? Well, the common factor of 1 and 5 is 1. And then the least amount of x's is 0 x's. So I can only take out a 1 here. And since I'm touching the negative 1x, I'll go ahead and take out the negative 1. So now the last step I do is I figure out what do I need to multiply each by to get the numbers inside. So I need to think, like, what do I multiply 2x times what will give me 2x squared? Well, there's already a 2 in the box and an x. The 2 and the x are covered, but I need a second x, so I need to multiply by x. So 2x times x will give me the 2x squared. I can also check that by saying negative 1 times x does give me negative 1x. Right, now I can think 2x times what gives me negative 10x. Well, there's already an x, so I need to think 2 times what gives me negative 10. Well, that would have to be negative 5, and that makes sense because I just talked about how I can take out a negative on any side that's touching a negative box. Now I can check that by saying, does negative 1 and negative 5 multiply to give positive 5 down here? Yes, it does. So the whole box checks out. All right, so now that we've done that, we can actually write our factors at 2x minus 1 times x minus 5 equals 0. And then I can just use my zero product property, set both factors equal to 0. 2x minus 1 equals 0, and x minus 5 equals 0. To solve the one on the left, I add 1 to both sides. 2x equals 1, divide by 2, x equals 1/2. Just leave it as a fraction, unless you really want to change it to a decimal. Then add 5 on both sides. X equals 5. Awesome. So we got 2 solutions for that one again. All right, let's go on to this last solving one. So it says 7 minus 3x squared equals negative 14. Well, let's see if I can use square root method. I see that x is already by itself here, so I can use the square root method. So I'm going to want to set up a do-undo chart. Some of you might help you to rewrite this a little bit. Now, notice that the 7 is positive, so you can kind of put a little imaginary plus in front of the 7 because it's positive. And then the 3x squared is negative, and then it's equal to negative 14. With addition, we can always change the order of things. So I'm going to change the order of this to say negative 3x squared plus 7 equals negative 14. That is the same thing as the equation above. It's just going to make your do-undo chart a little bit easier. Okay, so I just changed the order of that. So now I'm going to do my do-undo chart. So if you're ever confused when if you tried to make a do-undo chart for this and you got confused because of the 7 being in front of the negative 3x squared, just switch it like this. So I need to look at my x and think, what would I do first if I put something for x? Well, exponents come first. There's no parentheses, so exponents come first. So that means the first thing I would do is square it. Then I would multiply by negative 3, and then I would add 7. Okay. Remember, multiplying doesn't come first here because it's not in parentheses with x. So I've got to square and then multiply. So to undo this, I subtract 7, divide by negative 3, and then the opposite of squaring is square rooting, but don't forget the plus or minus square root. Plus or minus square root. So to undo, we're going to start with subtracting 7 on both sides. That leaves me with negative 3x squared equals negative 21. Then I need to divide by negative 3. Divide by negative 3. That leaves me with x squared equals positive 7. Now, finally, I get to take the square root. Don't forget the plus or minus with the 7. On the left side, you don't need a plus or minus because the square root just gets rid of the squared, leaves us with x equals plus or minus square root of 7. You could leave your answer like this, but some of you, I'm just going to write it out as x equals square root of 7 and x equals a negative square root of 7. And then some of you, and then from there, you can put it in your calculator to get an exact decimal. So if you put square root of 7 in the calculator, you get 2.646, and then that would be negative 2.646. So those are your 2 solutions. So for all these equations, we did get 2 solutions, but remember, you can get 0 or 1, especially when you're solving by square root. When you're factoring, if on a quiz for this class, if you're factoring, you're only going to see factoring problems that give you 2 solutions. For this quiz, you'll only see factoring problems that give you 2 solutions. So if you're factoring, an alert should go in your head that you're going to get 2 solutions. But with square root method, you might see one that gives you 2 solutions, one that gives you 0, or one that gives you 1 solution. If you end up with square rooting as 0, that means you're going to get 1 solution because square root of 0 plus or minus is just going to be 0 no matter what. And if you end up square rooting a negative, that's when you might end up with no solution. Well, you will end up with no solution because you can't take the square root of a negative. So just keep those things in mind. Maybe look over like the old homeworks or the exit card we did on that. Right, part 4, find the 2 numbers. So what 2 numbers? Multiply to 14 and add to 9. We should be pros at this because we already factored. So I'm going to look at the factors of 14, 1 and 14, 2 and 7. I think that's it. Which of these add to 9? That would have to be 2 and 7. So 2 and 7. What 2 numbers multiply to 30 and add to negative 11? Well, I'll make a little factor chart for 30, 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 and 6. All right, so they need to multiply to a positive and add to a negative. So that means that both my factors should be negative. So whatever I pick, they're both going to be negative. And then I need to look which of these would add to negative 11. Well, that would have to be negative 5 and negative 6. So negative 5 and negative 6. Put two numbers, multiply to -6 and add to -5. Well, I'll make a factor chart for 6. 1 and 6, 2 and 3. I need to multiply to a negative and add to a negative. So if I need to multiply to a negative, 1 should be negative and 1 should be positive. So I need to look at which one of these pairs has a difference of 5. That would have to be 1 and 6. Be careful. 2 and 3 do add to 5, but their difference is 1. And since one of them has to be negative, that wouldn't work. So I have to pick 1 and 6, but then I have to decide which is negative. Well, if I'm adding to a negative, then the bigger number should be negative. So 1 and -6. And lastly, which two numbers multiply to -36 and add to 5? I can make a factor chart for 36, 1 and 36, 2 and I think it's 18, 3 and 12, 4 and 9, 6 and 6. Remember, if you don't know these, you can just try dividing numbers in the calculator. So I need to multiply to a negative and add to a positive. So 1 is going to be negative, 1 is going to be positive. And that means their difference should be 5. So I'm going to look which of these has a difference of 5. That would have to be 4 and 9. But I need to add to a positive. So that means my positive number should be the bigger number. So 9 is going to stay positive, 4 is going to be negative. So -4 and 9. That's really good practice for factoring. All right, last part. Use the graph to answer the questions. First one, when f of x equals 4, how many solutions are there for x? So that's just, again, another way of saying when y is 4, how many solutions are there for x? So I'm going to go to where y is 4. And I'm going to see where does the graph touch at y equals 4? Well, or really, this one's just asking how many times does it touch? Well, the red graph crosses y equals 4 2 times. So that means there's 2 solutions for x. For what values of x does f of x equal 2? I'm going to use some colors so you don't get confused. So this was f of x equals 4. Now we're looking at f of x equals 2, so that's when y is 2. So I go to when y is 2. For what values of x does f of x equal 2? Well, that's here and here, which is x equals 2 and x equals 6. Name a value for y that will have only one solution for x. So there's only one spot where that works. It's down here because that's -2 is the only spot where the line we draw is only going to touch the graph exactly one time. So y equals -2. There's only one possibility for that. Name a value for y that will have no real solutions. Well, that's going to be anything below -2. Any line I draw below -2 is not going to touch the graph at all. So I can say y equals -3. You could also say anything below -3, even though it's not on this graph, you know that it's not going to touch anything below -3 because this graph is going up forever. So what's the domain and range? Well, I just showed you that there's implied arrows going up because quadratic equations, they go up for parabolas go up forever or down forever depending what way they're facing. And these arrows show that it's not only going up forever, it's going left and right forever. So the domain is -infinity to infinity. And I'll tell you a secret, for any quadratic graph, the domain is always -infinity to infinity for any quadratic graph, aka any graph you see on this quiz, that's going to be the domain. And then the range, how low does it go? Well, it goes as low as -2, and it does touch -2, so that's going to get a bracket, and then it goes up forever, so it goes to infinity. And you should be able to do that for any quadratic graph that could be given to you. Well, that's everything, so good luck studying, and good luck on the quiz.